Good day everyone, my name is Amanda Joanne, and before we go to know the type of irrigation system, I will be presenting about the introduction and the importance of irrigation system. So let's begin with the importance of water. Water is essential for life, for humans and plants. So did you know that about 60% of our human body is water? So water is used in almost every industry, from cooling and cleaning to producing electricity via hydropower. But in agriculture, around 70% of the world fresh water is used to grow food. So that shows how water is so important in farming system. So why exactly do plants need water? First, it's a key condition in the germination of seeds. Without water, seeds simply won't sprout. And also, plants themselves are made up of 80% of water. And water plays an important role in photosynthesis, respiration, and transpiration. And it also helps to transport nutrients from the soil to keep the plant's temperature balanced and helps maintain turgidity, where that's the firmness of plant cells. And lastly, it assists in moving important compounds from sources to sinks within the plant. So when plants don't get enough water, they go through what we call moisture stress. So, photosynthesis is reduced, which means the plant can't produce enough energy or carbohydrates, leading to lower yield. Secondly, transpiration decreases, which affecting the cooling system and water movement in the plant. So third, enzymatic activities are reduced, which it slows down the important metabolic processes. Moisture stress also delays nitrogen fixation, especially in legumes, affecting protein production. So in addition, plants under stress absorb fewer nutrients, which leading to deficiencies and weak growth. It also slows down cell expansion and division, which causing the plant to grow smaller and slower. And finally, low sugar pressure makes plant cells weak, causing wilting of. So what is irrigation? Irrigation is the controlled and artificial application of water to soil or land. So this helps crops, vegetation, and other plants grow when natural rainfall is not sufficient. So the main purpose of irrigation is to supplement rainfall and provide the right moisture for plants to grow in a healthy and productive ways. So this practice is important in areas where rainfall is insufficient or irregular, and it plays important role in agriculture, landscaping, and horticulture. So next, in agriculture, irrigation has several purposes. So firstly, irrigation helps to extend the growing season, which in places with seasonal rain, farmers can grow crops even outside the rainy period. So this allows more crop cycles in a year. Secondly, it helps to increase crop yield. So when plants get enough water, they grow better and give more harvest, especially in dry areas. And next, irrigation also helps to manage soil moisture. With controlled watering, the soil stays at the right moisture level, which is important for healthy roots and nutrient absorption. And fourth, irrigation systems ensure a steady water supply even during dry times, helping farmers overcome water shortage. Next, they also help prevent soil erosion. So by keeping the ground covered and moist, the soil stays in place and doesn't wash away easily, especially on slopes. And 6. Irrigation also helps to cool down the temperature in the field, which can protect plants during very hot weather. 7th, during drought, irrigation reduces the impact by giving water when there is no rain, which saving the crops from drying out. And lastly, irrigation systems can also distribute nutrients evenly when mixed with fertilizer, which helping plants grow strong and healthy. So, to manage irrigation properly, we must understand how water behaves in the soil. The first condition is called saturation. This is when all the soil pores are completely filled with water and there's no air left in the soil. So it usually happens after heavy rain or too much watering. This condition is actually not ideal because roots need air too, not just water. The second condition is called field capacity. So this is the ideal condition for plant growth. In this stage, large pores have air and small pores hold water. So it's the best time for irrigation management because it provides a good balance of air and water for roots. So the third stage is permanent wilting point. So this is when plants can no longer absorb water even though the soil may still contain some moisture. That's because the moisture is held too tightly by the soil. So you will see plants wilt and not recover even after waterings. So there's also temporary wilting points where plants wilt but can recover with water. And also ultimate wilting point where plants completely die and cannot be revived even with irrigation.
In general, there are four major types of irrigation. First one is surface irrigation, second one is overhead irrigation, third is drip irrigation, and lastly is subsurface irrigation. Surface irrigation is the traditional method where water flows over the soil surface to reach the plants. Meanwhile, overhead irrigations might mix natural rainfall by spraying water over the plants using sprinklers. The third one, drip irrigation, delivers water slowly and directly to the plant roots through pipes and emitters. Lastly, subsurface irrigation applies water beneath the soil surface directly to the root zone. Each system has its own advantages and is used depending on the crop type, budget, and farm conditions. Let's take a closer look at drip irrigation, which is one of the most efficient systems, especially in nurseries. In this method, water is delivered slowly through a network of pipes and small emitters placed near each of the plant. The water goes directly to the root zone. Among the key advantages, it saves water, reduces evaporations, limits weed growth, and lowers the risk of disease because the foliage stays dry. However, it also has some disadvantages. The setup cost is relatively high because it involves many components like filters, pipes, and valves. The emitters are also prone to clogging, especially if the water is not clean, and regular maintenance is needed. Even with these challenges, drip irrigation is still preferred in many smart nursery operations because of its precision and water efficiency. Next is overhead irrigation, which is also widely used in nurseries, especially in greenhouses. This system sprays water over the plants similar to rainfall. Sprinkler heads are installed above the plants or along moving lines, like rain guns or misters. Overhead irrigation is good for covering large areas and has a cooling effect in hot environment. It also helps reduce labor since it can be automated. But there are some drawbacks. Water distribution can be uneven, especially in windy conditions. A lot of water is lost through evaporation, and wet leaves can lead to plant disease. Even so, this method is still effective if designed properly, especially for plants that don't mind get foliage. Finally, let's briefly touch on surface and subsurface irrigation. Surface irrigation is the oldest method where water flows across the soil surface, like in furrows or basins. It's still used for some field crops, but in nursery system, it's not preferred due to inefficiency and uneven watering. Subsurface irrigation, on the other hand, delivers water directly to the root zone using underground pipes. This method is very water efficient and reduces evaporation losses. It also avoids wetting the foliage, which is good for preventing diseases. However, the cost of installation and maintenance is quite high, and once it's installed, it's difficult to repair or inspect. Both of these systems are less common in nurseries, but subsurface irrigation is gaining attention, especially in smart nursery setups that prioritize water conservation. First, let's look at surface irrigation. As you can see here, water is applied at the top end of the field and then it flows across the surface by gravity or by manpower. This is a simple method. No pumps or pipes are needed. The water travels through furrows or between raised beds and eventually soaks into the soil. It might look easy, but one of the challenges is making sure the water spreads evenly across the entire area. That's why land leveling is really important for this method to work effectively. Now, moving on to subsurface irrigation, this system is a bit more technical. Here, we have drip lines or pipes installed underneath the soil, close to the plant roots. When the system is turned on, water slowly drips out through emitters directly into the root zone. This method helps to save water and also reduces weed growth. Since the soil surface stays dry, you won't see any flooding or runoff like with surface irrigation because everything happens below the ground. Both systems have their own uses depending on the crop and location. Surface irrigation is great for large open fields, while subsurface irrigation is ideal for high-value crops where water needs to be conserved. So, That's a quick look at how these two irrigation systems work in real life.
Good afternoon everyone. Today I will be presenting on smart irrigations technology and essential innovations in modern agriculture. Let's begin with an overview of what we'll cover in these presentations. These are four main points we're looking into. Firstly, we'll understand what smart irrigation is, how it's work and why it's different from traditional irrigation system. Then, we explore the example of smart irrigation technology such as IoT-based system, fuzzy logic control, and sensor-based salinity monitoring. Next, we're looking at the benefits not just in terms of saving water, but also improving crops yield, reducing costs, and minimizing labor. Finally, we connect smart irrigation with the broader goals of the sustainability that's showing how this technology help conserve natural resources and support long-term agricultural practices. This topic is especially important today as the agriculture faces the dual challenges of increasing productivity while also protecting the environment. With that, let's move on the first point. What is the smart irrigation? So let's continue with the what is smart irrigations. Smart irrigation is a modern system that uses sensor, automations, and weather data to control water use effectively. Unlike traditional irrigations, it delivers water only when and where is needed. Based on the real-time soil and weather conditions, this prevents overwatering and reducing waste. Key features including the soil moisture sensor, automated valves, and the remote access that allowing farmers to monitor and manage irrigation using their phones or computers. In short, smart irrigation uses technology and data to make irrigation more precise, effectively, and sustainably. Next, there are three examples of the smart irrigations technology. The first one is IoT-based system. This connects sensor, valve, and weather stations through the internet to automate the irrigation using real-time data. Second, the fuzzy logic controller. They make smarter decisions by adjusted water flow based on the multiple factor like soil moisture and the temperature rather than just on of the setting. Third, sensor-based salinity monitoring. This system detects cell level in the soil and help prevent cell buildup in the root zone and protecting the crop health. Together, this technology makes irrigations more precise, efficient, and responsive. Next, I will talk about the benefits. First, it reduces water consumption by applying water only when needed. This helps save water, prevent overuse. Second is a lower energy and a labor cost through the automations. Less manual work is a requirement and pump run more effectively. Third is a help reduce crop disease caused by the overwatering and leading to the healthiest plants. And finally, with a remote access, farmer can control and monitor the system from anywhere and saving time and improving the convenience. Overall, smart irrigation boosts efficiency, crop health, and the cost saving. Next, we're moving to the smart irrigation and sustainability, which is the reduced water overuse. Smart irrigation supports sustainability by helping farmers use more water more effectively. Traditional systems often waste the water by overwatering or irrigating at the wrong time. In contrast, smart irrigation applies water only when and where is needed, using data from sensor and weather inputs. This prevents overwatering, reduce water wastage, and protect the crops from the stress. Smart system can save up to 60% more water comparing to the traditional method. That's a major advantage, especially in the area facing droughts or limited water supply. By cutting down unnecessary water use, smart irrigation supports the sustainability use of freshwater resources, ensuring there's enough water for the future's farming and the environments. So it's not about the convenience, it's a smarter, more responsible way to grow crops. Next is the managing salinity and the reducing runoff. Smart system can monitoring easy to detect salt level in the soil. This help prevent salt building up in the root zone, which can harm crops and reducing the yield. By adjusting irrigation based on the salinity data, farmer can flush out excess salt only when needed, instead of the over-irrigated. This keeps the soil balance and productivity over the long term. Smart irrigation also helps reduce fertilizer and chemical runoff. Since water is applied precisely, there's less chance of nutrient being washed away into nearby river or water sources. In the long run, this means healthy soil, less pollinations, and more sustainable crop growth, all supported through data-driven water management. Lastly, smart irrigations offer long-term economic and environmental saving. It's true that initial setup costs can be higher. Sensor, controller, and installations requirement investment, but over time it saves money in multiple ways. By using water more effectively, farmers see lower water bills. Automation also means less labor is needed to manage the irrigations. It also reduces losses from the crop disease caused by the overwatering. On top of that, better water management leads to the healthiest crop and higher yield, which means greater profit in the long runs. Environmental smart irrigations cut down on the resources waste and runoff, supporting the sustainable farming practices while improving the farmer bottom line. So, while the system may cost more upfront, the return over time, both economy and environmental, make it a smart investment.
Moving on to challenges and maintenance of irrigation system. The goal of this study is to address the problem and care required for effective irrigation system. The first common challenges for drip system is emitter clogging. Emitter clogging occur when organic material like algae or dirt and minerals such as calcium and iron build up inside the emitters. This leads to blockage, causing uneven water distribution. Some plants may receive too much water, while others get too little, resulting in poor plant growth and reducing crop yields. Clogging also requires regular maintenance and proper water filtration to prevent disruption. Second one is physical damage. Physical damage can happen from external factors like animals chewing through tubing or machinery running over the system. This leads to leaks, which waste water and reduce system efficiency. Regular inspections and repairs are necessary to keep the system functioning properly and avoid increased water usage. Lastly is salinity build-up. What is salinity build-up? Salinity build-up happens when high mineral water is used repeatedly over and over again. Over time, salts accumulate in the soils and within the system, clogging emitters and reducing water flow. So, excessive salt can harm plant roots and also reducing the yields. So, proper water management and leaching are important to prevent long-term soil degradation. Moving on to overhead system, the first common challenges are uneven distribution. It is occur due to improper sprinkler placement, inconsistent water pressure, or clogged nozzles. This results in overwater area and underwater ones, leading to inefficient irrigation. Wind can also affect how evenly water is distributed, causing some areas to receive more water than others, increasing water usage. Second is evaporation loss. Water droplets in overhead system can evaporate before reach the soil, especially in hot or windy condition. This reduces water efficiency, requiring more water to achieve proper irrigation. So scheduling irrigation during cooler parts of the day, like early in the morning or late evenings, helps minimize evaporation loss. Lastly is high setup cost. Overhead irrigation system required a significant upfront investment in components like pumps, pipes, and sprinklers. Skilled labor is also needed for setup, which increases the cost. Small-scale farmers may find these initial expenses prohibitive, limiting access to the system for those with limited budgets. Next is maintenance needs. The first maintenance that we can do is cleaning filters. Filters prevent debris, dirt, and organic material from entering the irrigation system, which could cause blockage in the emitters or sprinkler's head. Sand and screen filter are essential to maintain a steady water flow and prevent clogging. For sand filter, clean sand filter by removing and washing the sand or replacing it if needed. It's important to check for any debris built up in the filter beds. For the screen filters, remove the screen and rinse it under clean water to dislodge the dirt and particles. So, regular inspection helps maintain a smooth water flow and prevent emitters clogging. Second, inspecting emitters and sprinklers head. Regular inspections of emitters and sprinklers head ensure they are functioning properly. Clogs, wear, or damage can lead to uneven water distribution, which can harm crops by either over-irrigating or under-irrigating. So for the emitters, check for any signs of clogging, damage, or improper water flow. If emitters are clogged, clean them using a small needle or replace them if necessary. For the sprinkler's head, inspect for the cracks or blockage in the nozzles. Ensure they are spraying evenly across the area. Cleanse any debris that may have built up. The third one is seasonal checkup, which is before planting season. Performing a seasonal checkup before the planting seasons ensure that the irrigation system is in optimal condition. It prevents unexpected breakdowns or inefficiencies during the growing season. So firstly, inspect the entire system for any wears, leaks, or damage from the off-season. Test the system to ensure that it delivers uniform water across all areas. This includes checking water pressure and flow rates. Replace any worn-out components, for example like hoses, nozzles, or fittings. Last but not least is calibrations of water flow rates for uniform watering. Why? Which is to proper calibration ensure that each emitter of sprinkler had delivered the right amount of water at the correct pressure. Uniform watering is critical to avoid over or underwatering, both of which can affect crop growth and yield. So how to do it? Firstly, adjust the pressure at the water source or the individual components to achieve the recommended flow rate. Use a flow meter to measure the water output of each emitter or sprinkler's head, ensuring it matches the manufacturer's specification. And also, ensure uniformity by checking that all areas of the field receive an equal amount of water, adjusting the system as needed. The reason why we are using irrigation system is to prevent waterlogging and nutrient leaching. Poor water management can cause an oxygen deficiency. When water is applied excessively, especially in poorly draining soil, it leads to waterlogging, which fills a space in the soil. This restricts the movement of oxygen to plant roots, causing oxygen deficiency. As a result, plant roots cannot absorb essential nutrients properly, leading to stunt growth, wilting, and in severe cases, plant will die. Next is it can cause a salt building. Over-irrigation, especially with saline water, can cause salt build-up in the soil. When water is continuously applied, it carries salt toward the surface, where they accumulate. These salts, when concentrated in the root zone, can make the soils toxic to the plant. Why is these things matter? Because high salinity level can interfere with water uptake by the plants, leading to dehydration even when the water is plentiful. Next, it can also increase the pest risk. Waterlogging can create a favorable environment for pests and diseases, particularly those thrive in wet conditions like root rot, fungal infections, and certain insect larvae. Standing water in the soil attracts pests, which can damage roots and decrease crop health. Moving on to relation between waterlogging and nutrient leaching. So, waterlogging often leads to nutrient leaching. Leachings occur when excessive irrigation washes away essential soil nutrients, particularly nitrogen, potassium, and calcium, deeper into the soil or beyond the root zone. When water pools on the surface, it can cause the nutrient in the upper soil layer to dissolve and move downward, preventing plants from absorbing them. This further exacerbates the poor growth caused by waterlogging. Why is this thing matters? It is because the loss of nutrient from the soil means the plants don't get the nutrients they need for healthy growth, leading to deficiencies, poor yields, and overall reduction in soil fertility. Waterlogging and nutrient leaching can impact into soil fertility and environment. So, for the soil fertility, waterlogging and nutrient leaching reduce the soil fertility by washing away essential nutrients like nitrogen and potassium. This leads to poor plant growth and lower crop yields as the soil becomes less productive over time. For the environment, leached nutrient can contaminate groundwater and water bodies, causing eutrophication, which harm aquatic ecosystem. This pollution also contributes to the soil erosion and the degradation of natural resources, impacting the environmental. The first solution via smart system is automation reduce error. Automated irrigation system use a pre-programmed schedules and parameters to control the watering process. This significantly reduces human error, such as improper timing or uneven water distribution. By automating the process, the system ensures that each plant receives the correct amount of water, leading to more efficient irrigation. Next is real-time monitoring allows a quick fix. With real-time monitoring, irrigation system continuously track critical data such as soil moisture, water pressure, and emitter performance. This live data allows system manager to identify problems such as leaks or equipment malfunction immediately. A prompt detection and fixings of issue prevent system downtime and ensure uninterrupted irrigation. Thirdly is predictive control. Reduce overwatering system can advance algorithm and internal data, for example like weather forecast, soil moisture level, to anticipate the water needs of crop. By analyzing this data, the system adjusts irrigation schedules to avoid overwatering, ensure plants receive just the right amount of water. This not only conserves water, but also optimizes crop growth by preventing water stress.